Dear students, already we have seen two evidences for the structure of benzene. They are analytical and synthetic evidences. Now we are going to see other evidences for the structure of the same. Some scientists gave the structure and theory for benzene. So first is Kekulé. In 1865, he gave a structure and theory for benzene. That is, he suggested a ring structure for benzene like this. So this benzene, according to him, this benzene is having 3 double bonds with 6 carbon atoms and 6 hydrogen atoms. Each carbon atom is attached with 1 hydrogen atom, and all the 6 hydrogen atoms in benzene, no, they are equivalent. So that's why, according to him, we can get only one mono-substituted product with the 3 di-substituted product. So chemically, it is called as 1,3,5-cyclohexatriene. This benzene molecule is having unusual stability. That's why the chemists are representing benzene as a hexagon with one inscribed circle like this. Already we have seen the structures, and the first two structures, no, they are the resonating structures of the benzene, and the next one is the resonance hybrid. So the inscribed circle, that is the inner circle, no, that is representing that the valence electrons are shared equally by all the 6 carbon atoms. That is the fourth electrons. The now electrons in the outermost orbit, no, so that is the valence electron. So they are shared equally by all the 6 carbon atoms, and the corners are having 1 carbon atom, and that is connected to 1 hydrogen atom. So now we'll see the objections of the Kekulé's formula. If the Kekulé structures were correct, we can get 2 ortho isomers of dibromobenzene. In the first isomer, 2 bromine atoms should be on the carbons that are connected by means of a double bond like this. In the second isomer, the 2 bromine atoms should be on the carbons that are connected by means of a single bond like this. But actually, we are getting only one isomer. So to overcome the problems faced by the Kekulé, he suggested that benzene is a mixture of the two forms in rapid equilibrium. Already we have seen two resonating structures, no, that two forms. So he said that benzene is a mixture of these two forms in rapid equilibrium. And he has also failed to explain one point, that is benzene already that is having 3 double bonds, but that is not undergoing any addition reaction like other alkenes. Example is, it will not react with HBr, and it will not react with bromine in the presence of CCl4. So next one is class formula, that is next scientist is class. So to overcome the problems faced by the Kekulé, in the year 1867, he introduced one formula called as a diagonal formula like this. This formula is giving a reason for the simultaneous formation of two products, that is the ortho and para products. In the year 1882, he modified his own formula, that is, here the para bonds, no, they are not like ordinary bonds, and that's why they can be easily ruptured or broken. So the next scientist is Dewar. In the year 1867, he suggested many formula. He suggested so many formulae for benzene, and one is this one. So this formula, no, it is not perfectly symmetrical. That's why it is not accepted. Next scientist is Ladenburg. So in the year 1869, he proposed that benzene is giving 4 di-substituted products like this. So the first two are ortho products, next is meta, then para. So in the two ortho products, one is 1,2 product, another one is 1,6 product. So 1,2 derivative, another one is 1,6 derivative. But actually we are not getting structures like this. So that's why he proposed his prism formula like this. So here the 6 carbon atoms of benzene, they are at the corners of the regular prism, and that edges are denoting the linkages. This formula is not having any double bonds, so that's why it is not accounting for the addition product of benzene. Next one is V. Meyer. So in the year 1870, he opposed the Ladenburg formula. He said that 1,2 and 1,6 derivatives are differing only in the position of the double bond, and the difference is very slight. That's why he supported Kekulé's formula. Again, Kekulé in the year 1872. So according to him, the carbons in benzene are continuously in a state of vibration. Already he said that two structures were in a rapid equilibrium. So because of this vibration, this carbon-carbon pair, actually it is having carbon-carbon pair, no? So that carbon-carbon pair is having single bond half of the time and the double bond half of the time. So this is accounting for the oscillation between the two forms. So each molecule is spending half of the time in the first structure and half of the time in the second structure. So neither structure is representing benzene molecules satisfactorily. So benzene is a combination of the two forms. And all the bonds in the benzene are identical. It is not having single bond, not having double bond. So there is no real difference between 1,2 and 1,6 derivatives. Next one is Bayer in the year 1884 to 92. He wanted to decide the formulae for Kekulé and Ladenburg. That's why he carried out a detailed investigation of benzene. And finally, he proved that cyclohexane and hexahydrobenzene both are same. They are looking identical, and that is giving a reason for the cyclic structure of benzene. This is the point already said by the Kekulé. If you are removing one double bond from the benzene, saturation properties were lost, and this dihydrobenzene is behaving like alkadiene. It is not having any para linkages. That's why he rejected Class formula, Deva's formula, and also Ladenburg's formula. And finally, he concluded that benzene is having 6 carbon atoms and is not accepting the Kekulé formula. Only he is accepting only one point, that is benzene is having 6 carbon atoms and he is not accepting Kekulé's formula. So that's why he adopted a suggestion of Armstrong, and that is called as Armstrong-Bayer centric formula. So next one is Armstrong-Bayer centric. So according to this formula, the fourth valency of each carbon is represented as directed towards the center of the ring, like this. Here it is not actually linked to the opposite neighbor. That was in class formula, but here it is not connected to the opposite neighbor. This is not real, but this is potential. This centric formula is not in aliphatic chemistry. That's why this is responsible for the aromatic properties of benzene. And this formula is unsatisfactory for some compounds, like it is not explaining the stability of the ring and also the behavior of the polynuclear hydrocarbons. Now we'll see the objections of the Bayer's theory. So the aromatic properties are depending on the symmetrical arrangement of fourth valency of each carbon atom present in the ring. Two more scientists are there. They are Thomson and Stockman. They came to the conclusion that the heat of combustion of benzene was incompatible with the existence of 3 double bonds. In the year 1880, one more scientist called Brawl, he believed that the value of refractive index of benzene has proved its existence. Next scientist is Thiel. In the year 1889, he applied his theory of partial valency for benzene. So he has given a theory called as theory of partial valency of benzene and suggested the formula like this. So it dispenses with Kekulé's oscillation formula. Here there would not be any difference between the single and double bonds. So this is accounting for being no difference between 1, 2 and 1, 6 positions. So this is giving a reason for getting 1, 2 and 1, 6 positions. So at the same time it is also accounting for the saturation of benzene. If this formula is correct, then the aromatic character, because of the symmetrical conjugation of benzene ring, means the cyclooctatetraene is also exhibiting the aromatic character. So this is also getting an aromatic character if this formula is correct. Next one is Will Statter, last one. So he prepared a compound to test the Thiel's formula for benzene, and he found that it is having typical unsaturated properties. But because of a symmetrical conjugation, this is expected to resemble the benzene. So this lead to the revival of again Kekule's oscillation formula and some of the modifications mentioned, that is other than the Thiel's formula. Actually, the main problem with the Kekule's formula is according to Kekule formula, that structure is having 3 double bonds. But that 3 double bonds, and also they are in rapid equilibrium, no, that 2 structures were in rapid equilibrium. That is not explaining the difference in behavior between these double bonds with the polyphenic double bonds. So these are the points said by some scientists for the structure of benzene. Some other evidences are there. The first one is orbital picture of benzene, then resonance in benzene, and last one is the aromatic character of benzene. We'll see one by one in the further classes. Thank you.